Hi, I'm going to talk about DeMoivre's theorem and finding roots of complex numbers in trig form. Okay, the first problem. I'm going to relate this to DeMoivre's theorem, which we've already talked about. According to DeMoivre, z to the n equals r to the n cosine n theta plus I sine n theta. Now, as you know, roots can be written as exponents. So if I'm going to find the cube root, then its exponent is 1/3. So that means that what I'm really finding here is 8 to the 1/3 power times cosine 2 pi over 3 times 1/3 plus I sine 2 pi over 3 times 1/3. So that simplifies to 8 to the 1/3 power means the cube root of 8, which is 2 cosine 2 pi over 9 plus I sine 2 pi over 9. Now the difference is here that there are 3 cube roots. So what we have to do is take 2 pi and divide it by 3 to find the remainder of our cube roots. And the reason is that the roots are evenly spaced around the circle. So if we have three cube roots, that means that they are 2 pi over 3 apart. So what you have to do is take 2 pi over 9 and add 2 pi over 3 to get your next angle. So I'm going to have to multiply this by 3 so I have a common denominator. This is going to stay 2 pi over 9. I get 6 pi over 9. The sum is going to be 8 pi over 9. So that means this is my first cube root. My second cube root is going to be 2 cosine 8 pi over 9 plus I sine 8 pi over 9. Okay, so that's 2, but we know there's 3. So we have to take 8 pi over 9 and add to that, once again, 2 pi over 3. So this stays 8 pi over 9. This becomes 6 pi over 9. Adding together, we get 14 pi over 9. So my third root is 2. Let me try that again. 2 cosine 14 pi over 9 plus I sine 14 pi over 9. Okay, so that explains how DeMoivre's theorem figures into this. So, next problem. We're going to actually find the solution to this equation. So, what we have to do first is solve for x. So, x cubed equals negative 27i. And then we take the cube root of both sides. So I get x equals the cube root of negative 27i. Now, what we have to do is take the negative 27i and convert it to trig form. Well, this has a 0 because there's no a. Plug it into our formula to find r. That's 0 squared plus negative 27 squared, r equals. So r equals 27. Now we need to find the theta. Well, we're going to end up, if you do b over a, you get negative 27 over 0, which is undefined. So instead, let's look at where this complex number is located. It is way down here. And on the unit circle, that angle is 2 pi over 3. Sorry, I have that backwards. Let me erase it. That is 3 pi over 2. Okay, so now I can rewrite this in trig form. So I have z equals 27 cosine 3 pi over 2 plus I sine 3 pi over 2. Okay, I want to find the cube root of this because that's what it says in my equation. So I want to find the cube root. So z to the 1/3 power is 27 to the 1/3 power cosine 3 pi over 2 times a third plus I sine 3 pi over 2 times a third. So we get 3 cosine pi over 2 plus I sine pi over 2. Okay, now what we need to do is figure out the value that I have to add to the angle to get the other two roots. So we know that all the way around the unit circle is 2 pi. We have 3 roots, so we're going to divide by 3. So that means I have to add 2 pi over 3 each time to the angle to get 2 more roots. This is my first root. So what I have here to get my second root is I have to take pi over 2 and I have to add 2 pi over 3. I need a common denominator, which in this case is 6. So that's 3 pi over 6. Here I have to multiply by 2, 4 pi over 6. Adding those together, I get 7 pi over 6. Okay, so my next angle, or I'm sorry, my next root is 3 cosine 7 pi over 6 plus I sine 7 pi over 6. That's my second root. I need one more. So I'm going to take my latest angle, which is 7 pi over 6, and I'm going to add 2 pi over 3. Common denominator is 6. So I need to multiply by 2. I get 4 pi over 6. Adding together, I get 11 pi over 6. So my third root is 3 times cosine 11 pi over 6 plus I sine 11 pi over 6. And those are my 3 solutions to x cubed plus 27i equals 0.